Hello. So in this video, I'm going to quickly go through this Unit 3 activity, um, ex explain a little bit about what they're asking for, and try to make it a little bit more, I don't know, accessible. So in this activity, we're basically going to be creating a program that will guide a robot from one place to another. Um, so basically, the program is going to be, walk from your house to the nearest corner, walk one block east. If it's raining, do this. Otherwise, do this stuff. And if the sidewalk is closed, we'll do these things and then output our condition. That kind of stuff. So it'll be pretty, I don't know. It's not going to be a long program, but it is, there are quite a few steps that we need to go through to make this work. Now, to make this program work, we have to visualize a grid kind of like this, where let's say each block is 100 pixels, and our robot is smack dab in the middle at 400 and 400. We need to get our robot to, say, I don't know, 0, 0, let's say, right? Let's pretend like the house is there. And so the goal of this would be to get the robot to 0, 0. So there are a bunch of steps here to open up a new Python program and all of that. I'm just going to use Replit because I like Replit a whole lot more. It makes Python programming much easier. So I'm going to go ahead and open a new Replit project. And I will call this, it's going to be a Python project. I'm going to call it Robot Pathfinder. Okay. And let's go ahead and create it. All right. Now, while that's loading, let's take a look at the first thing we have to do. Well, we have to create a couple of variables. We have to create a variable for our x position, our position on the x of the axis. And we have to create a variable for our y position, our position on the y. And we're going to set both of those to be 400 at the beginning. So here in Python, I can literally just type xpos equals, let's say, 400. And we'll say ypos also equals 400. So we've created new variables, and we've given them some value. We've given them some data. In addition, you have to decide if it's raining or not and whether the sidewalk is closed. Those are two Booleans that we have to create. A Boolean is a special kind of variable that holds true or false data. So for us, we're going to create some Boolean variables. I'm going to call mine is raining. I'll say that equals true. And we'll say is closed. I'll set that to false. So we're going to pretend like it's raining in our program, and we're going to pretend like the sidewalk is not closed. Okay? All right, so next we have to put out some output. We have to output the position on the grid, wherever our robot happens to be. So the easy way to do this is to create a print statement. So the print statement would look something like this. Print, and then inside the parentheses, we would say, what do they want us to say? Your robot is located. Okay. Your robot is located at, and we'll use commas to separate xpos and ypos. Okay. Now, hold on one second. All right. Now I'm going to move this menu out of the way here real quick so I have more room here so I can see the whole line just on one. So right there, that's going to tell me that my robot is located at, and if you're paying attention to this program, you know that it'll say it's located at 400 and 400. So let me run the program and see if we get that result. And we do. Your robot is located at 400 and 400. Okay, perfect. So everything's working the way we expect. Now we need to get into updating our variables. So let's say we walk from our house to the nearest corner, and the nearest corner of the street to your house is 5 pixels south. So in order to go 5 pixels south, we would need to update our Y position, because remember on the grid, the Y is the up and down, so we need to go 5 pixels south. So we would say something to the effect of Y position equals Y position minus 5. Now, there's actually a shortcut that we can use. Instead of saying Y position equals Y position minus 5, we can just say that Y position minus equals 5. That's essentially the same thing as saying Y position equals Y position minus 5. We're subtracting 5 from Y position, okay? So we've gone down 5 pixels. And now we want to walk 1 block west or left on the x-axis. And 1 block is 100 pixels long. So then we can update our X position by 100 pixels. So we can walk left 100 pixels. Then we want to output this print statement again so we can see our updated position. So I've just copied and pasted that in. Let's go ahead and see what that looks like. So you can see we started at 400 and 400. But then we ended up at 300 and 395 because we went 100 pixels left and 5 pixels down. Okay, perfect. So we were able to update variables. Now we need to get into the conditionals. Is it raining? And is my path blocked? Okay. So to determine if it's raining, we need to use these Boolean variables here. So we can say if is raining, meaning if it's true that it's raining, then we'll do something. Now notice that there's an indentation, right? So the next line of code is indented 1 inside the if statement. That means that this line of code is going to be inside the if statement, and the if statement is going to make that actually happen, right? If it was outside of the if statement, then it would work by itself just like these lines of code do. But because it's indented, it means it belongs to the if statement. So we need to say we want to walk 2 blocks south, and we're doing that because I guess going south, the block has awnings. So we're going to walk 2 blocks south under the awnings, and then we're going to walk west 2 blocks. So we will update our Y position, Y pause minus equals 200. And our X pause is going to be also minus equals 200 because we're going south and then west. And then we want to output our position. Okay? So this says if it's raining, then we're going to go south first, then west. And our robot, and then we'll tell us, we'll put out to the screen where our robot is. Let's run it. And we can see there that it put out this third statement. It did that because it is raining. Is raining is set to true. And it updated us to now we're at 100 and 195. Okay. Now, if it's not raining, then we want to walk west 2 blocks, then walk south 1 block. So let's do that. So the way we can determine if it's not raining is basically if it is raining, we're going to do those things. If it's not, we'll handle literally everything else. So if is raining, we'll do these 3 things. Else, we'll do these things here. And what we want to do is walk west 2 blocks. So X pause minus equals 200. And we want to walk south 1 block. So Y pause minus equals 100. Okay, and then output our current position. So I'm going to copy this and paste it in. All right, so now the way this code works is if it is raining, we're going to go south 200 or 2 blocks first, then go left 2 blocks or west 2 blocks. If it's not raining, then we're going to go left 2 blocks first, then we'll go south 1 block, right? Now, if I run this, it'll be the same as what we have here because is raining is true. But if I change is training to false or is raining to false and run it, and clear that out, we can see that we have 100 and 295, right? So we have something different here. It's working exactly the way we expect. All right, now the last thing we need to do is we need to determine if the sidewalk is closed. Now this is only going to matter if it's not raining. If it is raining, we're not going to care. If it's not raining, then we need to check to see if the sidewalk is closed. So what we're going to do is inside of the else, we're going to have another if statement. Okay? And it'll say is closed. Now this if statement, notice that it's indented, which means it's inside the else, which means it's only going to run if we're already running the code that handles else. Okay, so we get to this Y position of, what is it, 295, and we're checking to see if that road is closed or not, right? And the reason why this only matters if we go this way is because if we're raining, or if it's raining, we completely bypass that block because we go down first, then over, right? All right, so we need to check. Oh, here we are. We need to cross over to the other side of the road. So we need to update our, let's see, probably our X position. Are we trying to go? Yeah, we're trying to go south. Yeah, we'll update our X position to be -5 because it says, or no, 2 pixels. So it says 2 pixels. So we'll move over 2 pixels. So X pause minus equals 2. Then walk forward 1 block. So Y pause minus equals 100 because we're going south at this point. Then we'll cross back over to the other side of the street. So X pause plus equals 2. So we're walking back to the other side of the street. And then we want to output our current position. Okay. So that's if is closed is true. So let me make that true so we can see if that actually works. So let's run it. And we do. We get that. So we started off at 400, 400. We went to the west, or we went to the nearest intersection. Then we went west. And then our robot went west 2 blocks and then south 1 block. And the robot and the road is not closed. So we crossed over to the side of the street, went south 1 block, and crossed back over to the side of the street. Okay. Then the last thing we have to do is tell them outside of this else. So we're outside of, well, actually, we need to handle if it's not closed, right? Or yeah, if it is, or if it's not closed, we need to handle that. And so that would just be walk forward 1 block. So it would be Y pause minus equals 100 and then output that statement. Okay. So now we've handled all of that. Now we need to just output a statement, and we're going to put this on the same vertical indentation level as everything else in our main part of the program. It's not going to be inside of the if or an else or an if or an else. We're just going to say print, you have reached your destination. Now I know that there are some of these things that some of these conditions, depending on how they're set, are going to make us have us end up in different places than others. But that's okay. This is just for us to practice using if-else statements and nested if-else statements and being able to update variables. right? So let's run it, see if it works, and it does. We get to our destination. Even if I change these, let's make it rain. We only get 3, but we end up with you reached your destination. We're always going to get this line of code because we're always going to run it. No matter what happens in these if-else statements, we're always going to get this line of code. Okay. So at this point, the program's done. That's exactly what they asked you to do in the category. And we can take a look at the rubric and make sure we did everything. Creating variables, we've done that. We've created variables for xpause, ypause, raining, and sidewalk, or is closed, the way I did it. Output, we've successfully outputted some strings concatenated with variables out to the screen. We've been able to update the variables of xpause and ypause. We have conditional statements handling whether or not it's raining or whether or not whether or not it's raining. And then we have a nested conditional statement that handles whether or not the sidewalk is closed. All right. So that's the entire project. Hopefully I didn't go too slowly. I just wanted to explain what we were doing as we were doing it. But hopefully that makes it a little bit more clear. Let me know if you need any more help. And yeah, thanks for reaching out. I love doing this kind of stuff. So anytime you need help, just let me know. All right.